Hi, can you guys hear me okay? So, my slide's working. Hi, my name's Warren Keil. So I'm going to share my path from a math major and to a data analyst to a full stack developer, and how I kind of just naturally found coding really useful and helpful along the way, and it was kind of just a natural progression for me. So a little bit about me: I did a master's degree in applied mathematics. While at university, I did research on machine learning and topological data analysis, among other things. After school, I worked as a data analyst for an energy consulting firm in Oklahoma City. And then after that, I now currently work as a full stack developer at Deep4 Technology. And yeah, as I said, my objectives for this talk is to kind of share my progression from just math student to full stack developer without taking any CS classes, and just how I found just coding to be really either required or just extremely helpful along the way. And hopefully inspiring anybody just thinking about it. Hopefully this will inspire people just to dive into coding and just pick it up if you can. So while I was doing my applied math degree, I took operations research. Operations research is it's one of the main courses in any applied math program. It deals with optimization. It uses a lot of probability theory, linear algebra, and other discrete math. And a lot of OR problems a lot of them are pretty hard to solve. Like, they take multiple pages to solve. And we weren't required to code, but since I was just coding as much as I could in grad school, I found out that coding greatly went along with operations research. So an example problem in OR is something like this. This is an optimization problem where this top function here, we would want to minimize this. This could be a factory that's producing 4 different things, each with a cost. And then they would be under the constraint that we have to produce at least this many according to these 4 equations below. So this is a problem you would get in university. Problems in the real world could have 100 variables, but even this problem right here might take a couple pages of writing of linear algebra to solve. So in this course, like for this problem and the other things in this course, I found coding useful because once you learn how to code your own problems and use the solvers, you immediately have the answer. And so rather than waiting to get a grade on your work or wait to see your professor, you know if you're right or not. And then also, if you're coding up by hand, you can put in breakpoints and you can check your intermediate calculations. I found that extremely useful. And then also, there's a lot of jobs that require operations research, and if you want to use this in industry, you're not going to be doing it with pen and paper. Like, it's all going to be programmatic. So if you are going to do a lot of the applied math, like use that as your real job, you pretty much need to learn how to code anyway. So yes, kind of how I found coding useful in operations research. Another example, I did a lot of machine learning at university. And machine learning, it refers to a class of algorithms that can learn from data. And it's the driving force behind artificial intelligence and data science. When you hear about AI or data science, the thing that's doing all the work behind the scenes are these machine learning algorithms. And it's made huge advancements in computer vision, natural language processing. It's why Teslas can pretty much drive themselves and a bunch of other things. With machine learning, coding is pretty much required to train and deploy your models. Python's the most common one. You can do it in other languages, but you pretty much, there's so many computations involved that you pretty much need to do it with code. Another huge part of data science is putting out visualizing your results of your models. And I usually do that in R or Python, but I'll do all that with scripts too. Also, when you're training your models, a lot of times you want to see the performance. You're constantly tuning and tweaking your models, and to do that, we usually plot the error function of that. And so it's another area you need to learn how to code. And then probably like the big part of data science. So if you're doing data science full time, probably 80% of your job is just fetching data, cleaning it, transforming it. engineering features from it. And to do all that, you're interacting with APIs, or you're writing web scrapers, and you're doing a lot of transformations in Python and stuff. And it's just, you're just coding the whole time. So yeah, I'm really into machine learning, and to do it, it just pretty much requires code. So yeah. So after university, I said I worked as a data analyst. And even though a data analyst job, it's a ton of statistics and math and machine learning, but all those things, it really, I was just coding all day long. I found out my job required me to pull data from many different sources, so I was constantly writing scripts to interact with APIs. I also was responsible for building and maintaining SQL databases and interacting with those. And then all the analysis I was doing, that we had to share that with decision makers. And to do that, you need to write plots. So I was constantly writing plots in R and Python to do that. And then along with the machine learning, like I had to clean and do a lot of transformations of the data using R and Python, just part of the analysis. And then I also did some machine learning models in my daily job. So yeah, just as a data analyst, I was just constantly in R or Python, it seemed like, the whole time. And so while I was still working as a data analyst, I took on a side project, and this is kind of the project that kind of got me into full stack development. I talked to a local tech firm in Oklahoma City, Deep Fork Technology, and they had a client that wanted to do revenue prediction. And their client had data and they had data on like about 100 companies in Oklahoma City, and he wanted a machine learning model to be able to predict that. And I knew a good model that would do that. It's a LSTM, deep learning neural network model. And so I took on the job, and I learned about APIs. So I spun up a Flask API and deployed the model there. And me and the other dev helped me out, and we integrated their existing software and existing database with my API. So he could just click some buttons in his current software, and it would ping my API. My model would do its work and send the results back. And so it kind of was like all contained in his existing software. And that's kind of when I kind of realized, like, with machine learning, like, there's so much development that's required anyway. If I just learned front end and back end development, it would just remove a lot of the other limitations of it. Plus, I was really interested in learning it, and so that's kind of how I got into full stack development. Deep Fork gave me a job, and then ever since I've been doing full stack development in React and .NET, and also mobile development in React Native, and absolutely love it and highly recommend it. So yeah, my conclusions was it was kind of natural for me, but just from being a math student to a data analyst to of course now, I just always found, like, even if you're going into full stack development, just doing math or statistics, like learning how to code is extremely useful. Or if you're a data analyst, knowing SQL and knowing how to use R is super useful. And I found it useful all the way, and that was kind of my progression into a full stack developer. And so I'm open for questions if anybody has any.